In the previous section, I talked about marginal cost. Marginal cost at any production level is just the cost of the next item. And we could do that with two formulas. One was the technical formula and one was the derivative formula, which usually approximate it. And in the last section, you may remember I did an example where those two definitions didn't really match up very closely. Here's another version of that idea. The cost of producing X items is the square root of X, $100. So A is asking us, what is the cost of producing 100 items? Let's write this in function notation. Cost of X items is the square root of X, $100. Well, then the cost of 100 items would just be the cost at 100, which is the square root of 100, which is just $1,000. Which looks a little weird to say. What's $1,000? 1,000. Okay. What about 101 items? Well, this one's a little messier. The total cost of 101 items is going to be the square root of 101, which, I don't know, we're going to need to use a calculator to approximate that. What's the square root of 101? About 10.0499. $100. So what that looks like is about $1,000, $1,004.99. A little messy. So remembering what marginal cost is, what is the cost of the 101st item? That's the marginal cost at 100 items, the cost of the next item, the 101st item. And it's just, what's the total cost of 101 items? What's the total cost of 100 items? This is how we could write it in math. Or you could just look at these two things. 101 is $4.99 more than when you produce 100. That marginal cost is going to be $4.99. Okay, so at that production level, if we want to increase production, it's going to cost us about $4.99 per item. Now let's use the marginal cost implementation. Oops, I forgot to update this. Should say C prime. Okay, not F prime. I renamed it C. Well, C prime of X, we need the derivative. Just like before, if we take the derivative of a square root function, it's usually easiest to rewrite it first. A square root function means an exponent of 1/2. And if you remember from algebra, a cubed root would be an exponent of 1/3, etc. And now we can take the derivative. The derivative of this function is just the power rule. Bring down the exponent, subtract 1 from the exponent. 1/2 times x to the negative 1/2, which again, negative exponent means denominator. 1/2 means square root. This is our derivative. This is the derivative of our function. Okay? You do that out in steps, you should get to the same place as I did. Now it wants us to find C prime of 100. Now remember I said if we want to find the derivative at any place, we have to find the derivative function first. Said that up here. Must find the derivative function first and then plug in the number. The order is important. So the marginal cost at 100 items can be seen in this framework as well. The square root of 100 is just 10. What's 1 divided by 20? 0.05. And you might get a little suspicious. You might say, Jason, you did it again. Those are nowhere near each other, right? $4.99 and 0.05. But remember, what are the units? The units of a derivative are the units of the original function. What are the units of our original function? Hundreds of dollars. So this is hundreds of dollars per item. Okay. So rewriting that, that's $5 per item. Okay. So you can see $5 and $4.99, those are pretty similar quantities. I'm having different units here because it kind of depends on the formulation. Here, this is a cost minus a cost. So our answer is going to be a cost. Here, this is a rate of change. So our answer will be as a rate of change. But there are two ways of thinking about the same idea. If we're producing 100 items, additional items are going to cost us about $5 per item. Okay. Technically, that next item will cost $4.99. But on average, each additional item around those parts, because it'll change, will be about $5 per item. That's how we can look at the two definitions of marginal cost and see that in a lot of times they're similar. Furthermore, a lot of times one is easier than the other. And this definition over here lets us do some fancy calculus stuff with it later in this chapter. We're not going to talk about that today, but later in this chapter, we do cool calculus stuff with the second definition. And that's why most of the time for marginal cost, we'll be looking at derivatives instead. It's not just because I want to put calculus in everything. There are some advantages to it. Anyway, that's all for this video. Got more videos coming. Take it easy. Bye-bye.